Hey y'all, we're going to cover chemical reactions and how to write equations. The first thing I want to put up, and this is where I encourage you to stop the video and copy this down. These are your 4 types of equations. The 4 types are synthesis, decomposition, single displacement, and double displacement. With a synthesis, you have 2 elements come together to form a compound. Decomposition, a compound breaks down into 2 elements. So think of something that is decomposing. A single displacement, you might also find the word written as replacement, is where you have an element in a compound and then they swap partners, yields an element in a compound. The double displacement or replacement are all compounds and they swap partners. So what is happening, and this is where you have to remember what is positive and what is negative. Positive and negative. The positive ions are called what? They are cations because they are positive. Your negative ions are called anions. So remember, your positives are metals, negatives nonmetals. Those form what type of bonds? A positive and a negative forms an ionic bond. 2 negatives, covalent bond, and 2 positives, metallic. So here you'll have the positive and the negative breaks down into positive, negative. Positive, positive, negative. These swap according to what is positive and negative because they want to go together just like the ends of the batteries. So this negative will then join this positive because these 2 can't be together. So that's why you have B by itself and then AC, positive, negative. And here, positive, negative, positive, negative. Those 2 come together and those 2 come together. You have to write your positives first. So they have to be written in this way, positive, negative. So pause your video and copy this down. This will be really good for you. Make sure you get this down on your 4 types of equations. Now I want to talk about some examples. Well, you know me, I can't find my stuff. Okay, so here are some examples, and I want to go through some of these to identify. Here you have a compound and it is breaking down into 2 things. So that is your decomposition. Here you have a compound, a compound, a compound, and a compound. So that is going to be the double. Element, compound, compound, element. That is a single. And here you have 2 elements coming together to form a compound. Element, element, compound. So this is going to make a synthesis. So if for practice, if you can pause the video, and if you will, either you can type or you can write down the rest of these, shoot them to me. I'll check them for you. I don't have to grade this, but I want to make sure that you are keeping up with the material, and I want to be able to give you that feedback and to correct your work to help you. I know you're having to do a lot of independent work, and I want to take some of that pressure off of you, and I want you to still feel like that you know I'm here to help and here to teach you. So practice these. You don't need to write out the entire equation. But if you would like for me to check these, this is going to be tested on later, and you will have some quizzes, assignments that will be posted for this. So go through these and practice these. zoom in for this, okay? Now, next thing I want to talk about diatomic molecules. There are 7 diatomic molecules. Now, they are written like this. Remember, as you do in class, if I write it down, you write it down. You have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. 1, 2, 3, 4, 5, 6, 7. There are 7 diatomic molecules. Prefix di, remember mono, di, tri, tetra, penta for covalent bonding. Di means 2. So these elements, anytime you write an equation and they're by themselves, they will be written as a 2. For example, if I am mixing hydrogen and oxygen and I want it to form something, hydrogen I have to write as H2 since it's this. This does not have anything to do with an oxidation number. This 2 is simply because it's a diatomic molecule. Di means 2, atomic, so this literally translates into 2 atoms of hydrogen. That's where this comes from. So I would write hydrogen, and then I have to write oxygen by itself as well. Yields, well, we know if you mix hydrogen and oxygen together, you get water. Point to note, this 2 does not come from the 2 on your hydrogen. This 2 is what you've been doing all along with hydrogen oxidation is a +1, oxygen oxidation is a -2. So that 2 comes from that, and that 1 crosses. So these are how you write diatomic molecules. The next question to ask you is, what type of equation is this? You have an element, and you have a compound. So what equation is this? Synthesis. Synthesis. Another thing, while we're here with this, you have the elements on this side of the equation. And you have an element on this side of the equation, or compounds. Everything to the left of the arrow are called reactants. Everything to the right of the arrow are called products. This arrow means yields, kind of a therefore. So in case of yields. So this is done this way because these elements react together and it yields, it forms, it makes the products. Products produce. So this is what is produced from the reactants. Reactants yields products. So in review, and this is a shorter video and kind of getting you started on the types of reactions. Diatomic molecules are written by themselves. Let me do another example to show you how that's done using diatomics. So let me make up something here. I am going to have strontium plus potassium oxide. Okay, and I want to make that into a compound. The review for this would be, how is this going to be written? You have Sr, strontium by itself, K2O. That 2, because you know oxygen was a -2, potassium's -1. Strontium's +2. Yields. These are switching sides. So now strontium is going to join oxygen. You have to keep your positives and your negatives together. So that's a +2, that's a -2. Potassium would be by itself, plus SRO. The 2's cancel out, so it's SR. Reactants, yields, products. And what type of equation is this? An element, a compound, an element, and a compound? That is a single displacement, because you have a single thing that is always left out of its own. You don't write 2's on these because potassium and strontium are not diatomic molecules. They are not diatomic molecules. Do another example of this for you. We are going to write hydrogen plus barium chloride. Barium chloride's +2, chlorine's -1. That 2 is written there because it's a diatomic. That's a plus. That's going to swap and get with that negative and leave barium by himself. So then you'll have barium plus HCl, +1, -1. No subscripts. Element, compound, element, compound. This is a single displacement as well. So I'm going to stop the video here, give you a chance to go back and practice that worksheet. Some of the sheets that I posted online asked for you to let me know what type of equation it is, single, double synthesis, decomposition. You can do that part. The next video that I'll make is on how to balance the equations, which was some of the other sheets that we had. So please keep up with your work. The easiest way to let me know what you're doing is you can always write it on paper, take a picture, and email it to me, or share it with me on Google. If you are preferring to type all of your answers, open the files that I posted in Google Classroom. And when you open it, you want to open in a new window. Once you open that in a new window, download it as your own individual copy. That way you can modify your personal document. Then you save that and you can email it back to me. You can share it with me. If you have a tablet and you want to write on it, you can do that as well. So my phone's ringing. I'll end the video here. Let me know, call me, message me with questions. Bye.